Good morning, everyone, and welcome to this awesome four-part webinar series we're calling Getting Schooled by Siggy. One of our industry's best-known and passionate teachers, John Siegenthaler, PE. John has a 35-year track record of passion for water-based engineering, and he likes to share that passion with all of us. So thank you for all of you to join us today. I am your host, Dan Ashenden. I'm the group publisher for BNP Media and for the Mechanical Plumbing Group, which includes three well-known brands in our industry, which John writes for. And the first one is Plumbing and Mechanical, which is the #1 contractor-focused brand. The second is PM Engineer. It's the leading voice for plumbing and mechanical engineers. And then Supply House Times, which is the official publication and brand of the ASA for wholesale distributors. This webinar series is brought to you by Caleffi North America with their outstanding hydronic solutions. Caleffi's partnered with BNP Media to offer you this complimentary four-part mini-series presented by Siggy. So for the next 4 Tuesdays, including today, this series will help you understand how to design, construct, and commission a hydronic and heating cooling system that will leverage today's low energy using technology while keeping things as simple as possible. After all, we all know that comfort plus efficiency, high efficiency, equals a happy customer. The Getting School planned here will include 4 parts, as I mentioned. And part 1 today is what the customer wanted and what the engineer designed. And then the following succeeding Tuesdays, part 2 will be June 9th, and that will be on heating and cooling sources, air to water to geo. And then part 3 is June 16th, and that'll be heat emitters and direct hot water and air handlers, and it's all in the details. Then finally, part 4, which will be June 23rd, and that's the final exam. And that's on controls, performance, and lessons learned. But don't worry, you can't flunk the course. So you will receive a certificate of attendance emailed to you for your continuing education. So really, without further delay, we got a lot to cover here. And without further delay, let's bring on John Siegenthaler, Siggy. And I understand we have a special guest today with Bob Hot Rod Rohr. Siggy, are you there?
I'm here. I'm going to let Hot Rod do these intros real quick.
Yeah, hi. Right. Welcome, everybody. Thanks for joining us today. Hi, Ted. Hi, Drew. Hi, Ted and Max and Norman and Wes and people we know out there. Thanks for joining us today. So yeah, just some information here. If you have trouble with the connection or something like that, you can call tech support at GoToMeeting. Oftentimes, if you just hang up and dial in again, you can clear up a bad connection, or if you have a staticky connection or something like that. And these will be posted to YouTube. Give us a couple days to a week to get them up on the Caleffi YouTube channel, and you can watch these again or pass them along to somebody else. So I think that's about all you have, Siggy, for housekeeping. I'm gonna let you go. I know you got a lot to talk about. Thanks for coming today.
Yeah, it's good to be here. And again, Dan, thank you on behalf of BNP Media. Great to see the partnership there. So let me go right to my first slide here. We put this session, this mini series, as we're calling it, together. We put it together as an outreach during the COVID situation here. We know that some of the HVAC professionals are, I'll say, temporarily displaced from your normal duties. So we were putting together different ideas. I know Bob has done several sessions there at his workshop and has some really interesting things, some really nice demos. So we put this together and we were kind of brainstorming about topics for this. And I had the good fortune last year of actually participating in building a new house. And of course, we selected a hydronic heating system. Now, this is not a house for myself. I'll show you the clients here in a minute. But what this mini series is about is I'm going to show you quite a bit about this house. We're certainly going to focus on the heating and cooling as the primary topic. I want to show you how that integrated into other aspects of the house. The insulation system, the actual layout of the house, the land that was available that allowed us to do a geothermal heat pump, and just kind of how these different elements of construction and mechanical trades came together in this project. And you'll see here a lot of different hydronic concepts. We used chill water cooling, for example. We used buffer tanks. We used several different types of controls. One of the overriding goals here was to meet the objectives of the clients and also keep this system simple, keep it reliable, use existing technology to the fullest extent. And what we're going to do today is going to be kind of an overview of the project. I'll show you several photos during the construction, and I'll finish up towards the end today with a schematic of the overall heating and cooling system. And it might look pretty complicated when you first see it, but over the mini-series, what we're going to do is disassemble that overall schematic into subsystems. Subsystems, for example, for floor heating, another subsystem for domestic water heating, another subsystem for cooling. And we'll talk about the design of those subsystems separately, and then we're going to put them back together again. And in the process of doing that, I want to point out techniques like hydraulic separation, reset control, how we piped up the buffer tank, and so forth. Okay, so today we're going to move ahead. We're going to talk about the clients and what were their expectations. And as you'll see shortly, they're kind of unique clients. I'm going to give you the overview of the new house. We're going to look at how the construction progressed. You'll get to see what the layout of the house was and so forth. And we'll finish up, as I mentioned, with a kind of an overview of what the heating and cooling system is. So here are the clients. This is Andrew and Heidi Jones and their 2-year-old son, Henry. And I mentioned they're kind of unique clients because Heidi's maiden name was Siegenthaler, and it's not a coincidence. She is my daughter, and we had the great fortune of having them move back into our area. They were originally living down in the Albany area. They moved back to this area, and I think it was February of last year, we got a call, well, Andy's got a new job, and we're coming back. And it was kind of a situation where we had to move pretty fast. We had planned, we had some initial discussions about someday maybe you'll come back, and we have some land available if you want to build a house. Well, as of February last year, everything went into full speed on that. So here's the house. I'll show you a lot more photos of this. This is kind of looking at it from the southeast. Back in December of last year, you'll see the deck isn't finished there yet. And here's what that schematic is going to look like, or does look like. And you'll see there's a lot of parts and pieces here, but what appears to be complex, as I said, we'll take this apart and we're going to look at each of these in more detail. So what were some of the general design considerations on this project? Okay, well, like any construction project, you've got what the clients want, what Heidi and Andy wanted in the project, the site considerations. This project is a very short distance from where I live. What kind of a budget do we have to work with? We do live in upstate New York. It is a cold winter climate, and I'll show some photos that'll prove that. And yes, a lot of different considerations coming together here. But some of the ones that we really wanted to focus on, we wanted quality construction. We want this house to last a long time. It is wood frame construction, but we used what I'd consider good materials. We used, for example, Douglas fir plywood rather than yellow pine plywood. It's a little more expensive, but it tends to hold up better. The bolts that hold the deck together, they're all stainless steel, so they aren't going to corrode. So we didn't go crazy, but we try to really be careful about selecting materials that are going to hold up for many years. We also wanted to use those materials efficiently. I'll give you a little bit more of my background. My dad was a carpenter, so I spent time working on projects like this when I was growing up, and we learned to work with different materials. And for example, you know that a sheet of plywood is 4 foot by 8 foot. So you can build a house that is, for example, 47 feet wide, or you can build a house that's 48 feet wide. You're going to use the same materials because of the sizes they come in, And you're probably actually going to spend more money to build a 47-foot wide house because you're going to end up cutting those materials. So there's labor involved there. And you're also going to end up having to dispose of the waste materials. So we try to think through what's the efficient way to use framing materials, in particular insulation materials. And we also wanted to design this in a way that would be a relatively fast construction. And I'll show you some more slides, but you can see some photos up here. These are attic trusses that give us a living space in the attic, so it's a fully conditioned attic. We use some spray foam here. We used a lot of engineered framing materials, and we were very pleased how fast these materials went together for us. So, we also wanted low maintenance. It does have vinyl siding. There's really virtually nothing on the outside of this house that needs painting and so forth. So that was one of the client requirements. We want to coordinate with local resources, and actually one of the best local resources that we had are Amish cabinet makers that literally are 3 miles from the site. And you see my daughter here. Here's a photo back when they were constructing those cabinets. They put together a really nice kitchen, and they didn't use any electricity in the process of it. It's amazing the craftsmanship that they had. So we also wanted to have good integration with the site. So part of energy efficiency in a building is orientation. This building is oriented directly north-south, so we get really good solar exposure on the south side. There are more windows on the south side, so we get passive solar gains there. We oriented it with respect to some of the trees on the site, so we would get sheltering from prevailing winds. The site did have a slight slope to it towards the south, so we're able to open up the south side of the basement, make it a walkout basement, give us more exposure to the sun, and also protect that portion of the structure by, berming the earth up against the basement walls, and making use of that existing slope for good drainage. The footings, for example, on this all drain out to daylight. There's no need to have a sump pump in the basement. So those are all just parts of planning a project from the standpoint of the structure itself. Okay. Now, design considerations for heating and cooling. Right off the bat, Andy was a big fan of geothermal heat pumps. He'd studied them. He'd done quite a bit of research on them. And as you'll see in a minute, we did have enough land area available to do a horizontal earth loop. So a geothermal water-to-water heat pump was definitely on the list to integrate into this system. We wanted to keep the controls simple. We have a simple, what we call master switch. It has 3 positions. The center position is off. You flip the switch one way, the entire building is in heating mode. You flip the switch the other way, the entire building is in cooling mode. Now, that doesn't preclude that we can do things like zoning, but we don't, for example, have the ability to heat bedroom 3 and cool bedroom 2 simultaneously. Okay. There were some areas where floor coverings precluded the practical use of floor heating. And one of the big considerations in this system, since we're using a heat pump for providing warm water for heating, we want to keep the operating temperature on that system as low as possible to maximize the performance of that heat pump. So when we have some floor areas that we're going to get carpet and pad on them, we ran some numbers and we found we just aren't going to be able to get the adequate heat transfer through that carpet and pad using water temperatures that would also allow the heat pump to operate at high coefficients of performance. So we decided to go with panel radiators in those areas, and it actually came out really nice. We did talk about zoning with cooling, but we decided in the interest of simplicity and cost, we're going to use the whole house is going to be a single zone in cooling. So we have an air handler that'll have chill water going through it. The cooling load's about 3 tons, and the entire house is cooled as a single zone. Now, in this rural area where we live, we do have power outages. We've had 2 of them already this year due to thunderstorms, trees coming down on power lines and so forth. So we did one, I guess I'd call it our backup plan was if we had a prolonged power outage, how are we going to heat this house? So there's a small wood stove installed in the house, and we've got plenty of available firewood. And so that worked out really well for a backup. Now we do have a thermostat in the main living area, and it has a heating and cooling function to it. So right away now we're dealing with a combination of a thermostat controlling heating and cooling in one area, and thermostatic radiator valves controlling heating and cooling in other areas. How do you bring those 2 together? Well, that's one of the beauties of modern hydronics. It's actually fairly easy to do that, but you do want to think it through in terms of what areas are being controlled by what devices. Now, floor coverings. I mentioned we have various floor coverings. The kitchen that has engineered hardwood, moderate R value. We were able to work with floor heating. We use an underfloor tube and plate system that you'll see coming up in another episode. The living room also had engineered hardwood floor, but they wanted a large area rug and a fairly plush area rug. So again, we looked at that, and the R value of that area rug would have required significantly higher water temperatures. So we abandoned the idea of doing floor heating in that area and instead went to a couple panel radiators. Bathroom, ceramic tile. Again, low R value, so we could do floor heating in those areas. But Heidi and Andy wanted to go with carpet and padding in the bedrooms. So again, R value too high for floor heating. So you can see right away here where the design constraints that you're working with, and those of you that are familiar with floor heating, you know that R value of floor coverings is really important. You want to evaluate that. And in general, unless it's a thin carpet, like a commercial low pile carpet glued down to a slab, generally speaking, carpet is not your friend when it comes to floor heating, especially if you're trying to keep those water temperatures low to maximize performance on your heat pump. So again, there are a lot of things going into the bowl here that get mixed together. So here's what the site looks like from Google Earth. This is, again, rural farm country, upstate New York. And you'll see this blue line here. This is basically a 2.5 acre lot. There was a farm, there still is a farm across the road. And originally, you'll see all these spruce trees that were planted here. These were planted originally as Christmas trees. They weren't planted very well. Some of them actually didn't make it very, very far. But the lot had quite a few of these trees, and this yellow is where the house is going to go. And you see a couple ideas on driveways. These were kind of early plans. Do we take the driveway straight up through, or do we curve up here, and so forth? But one of the things we had to do is remove quite a few of these trees. And the other thing about this lot, you can see there's a lot of room here, even if you go around the trees, and we actually did. Our earth loop actually comes out and kind of curves around down through here. We had the room to do a horizontal earth loop. We didn't have to bring in a drill rig to do that. And locally, we've got several people that do excavation. So the cost of doing the horizontal earth loop was much better than doing vertical boreholes. So here's what it can look like up here in the winter. And I'll confess, I did pick a day with a fairly stormy photo here. We're at about 7,500 degree days. Most days the snow falls horizontally up here. So we got a good wind going here. We got some drifts. This is a cold, challenging winter climate for a house, okay? And I came to the conclusion years ago that if we live up here, you need a tractor. So that's actually my tractor. That's how we clear our driveway, with the front scoop on the front there, all right? But it's beautiful in the summer, absolutely beautiful. We have maybe about 10 days where we need cooling going on. Most of the days our temperatures are 70, 75 degrees. This is just a really nice calm evening. You got a little ground fog there. Open the windows. It's really beautiful in the summertime. So if you can handle the winters, the summers are really nice. So here's kind of the starting point. Well, we actually did a lot of work before this, but as you know, to begin a building, you need a building permit. So we submitted our plans, our specs, and we got our building permit. We're clear to start making noise. And one of the first things we did is start clearing the trees, especially where the house was going to go. So we were over there with the chainsaws dropping these trees down, and you can see we got some stumps to deal with too. Dragging the trees to a pile. Eventually, we did end up burning that pile. The stumps actually got buried, but site clearing was going on late April and May last year. We've got a local excavator here. His name is Alhidas. This fellow's 84 years old, the guy driving that excavator, and he still does beautiful work, climbs right up in there. Great guy. I've known him for 40 years. So we're fortunate enough to have Al and his son Wayne as our excavating crew on the project. Okay, now I'm going to stop this and just explain. This fellow is a well driller, and what this little short video is going to show you, if you look, a little hard to see it right here, but he's got a couple brass rods that have a 90-degree angle in them, and he's holding them in his two hands, and the rods are pointing straight out. And when I turn the video on, you're going to see him walk forward, and if you watch really carefully, you'll see at a certain spot these rods both go horizontally. They change orientation by 90 degrees. And he's going to mark that spot, and then he's going to come back in the other direction with the rods, and they're going to do the same thing. So this is called dozing for water, or water witching is another term. I don't understand the physics of it because the brass rods are not magnetic, but I just want to have you folks watch what he's going to do here. So the rod's turned right there. So now he's going to come back in the other direction. And there they turned again. So he kicks the ground. Now you can see it a little better here. And they turn out. So he puts them in the ground, and X marks the spot. That's where we drilled the well, and we did get water about 180 feet down. We got a good supply of water. Now, one of my jobs back last May was to build the driveway. So this Alhidas at 84 kept driving his dump truck and bringing loads of gravel, and I'm pushing it in here with a bobcat. We had in places to build that up about 30 inches. We actually had to build the driveway to get the well drilling rig in place. We had a very wet summer last year. The lot was a little soggy at this point. So bringing a truck in with a well drilling rig on it without a decent base, there's no way that truck's going to make it to where we had to put the well. So we actually built a driveway long enough that we could get the well drilling rig in there. And then after he was done, we moved that gravel back up and used it on the main driveway area. So again, a lot of site work. Okay, here are the plans. I drew these plans up in a CAD system, and I worked with Andy and Heidi, and we did a lot of variations, as is typical. But it's a fairly basic house. The main house itself, it's got a full basement, main floor, and then the attic trusses for the second floor. It's got a breezeway here that connects out to a 3-stall garage over on the east side. So on the north side, there's a few windows, and of course the driveway comes in to these overhead doors. My daughter wanted a yellow front door. I'm not sure what that's about, but she got her yellow front door. Here's the south side, facing directly south, more windows there. And we were looking at integrating some solar electric systems into this. You'll see right now we do have solar electric on the garage, and there's potential to put more of it over here on the house later on. And then just the east and the west elevations. So that's what it looked like on paper. here's what it looked like as of last December. So there's the house, the garage. This is kind of looking from the northeast, and here's the view from the southeast. Here's the photovoltaic system on the roof. Let me just run through some of the stats on this real quick. It's about 3,300 square feet of finished space. There is a lot of space in this building. We didn't leave much space that isn't accounted for some purpose. There's pretty good R values. I wouldn't call this a passive house, but it's approaching that. We've got R29 in the above grade walls. It's a combination of spray foam and mineral wool. Basement walls are R24. Lots of insulation up in those roof cords, those truss cords, R51. And then all the glass in the house is a triple pane with a low E coating, which is just under an R4 rating. So the design load on the house itself, excluding the garage, is 35,000 BTUs per hour. And that's at about a -10 outside design temperature. That works out to just under 11 BTUs per hour per square foot for the building. So this is definitely a low energy use building. The PV array that's on the roof now, that's a 7.8 peak kilowatt output. It uses microinverters. Each of those little panels has an inverter. I should say each panel has a small inverter in it, and each inverter records separately how it's doing. So you can actually pull an app up on your phone and look at what each panel is doing, and get the totals for the day and so forth. Very interesting system. It was designed as an all-electric house, and I mentioned you'll see a chimney here, and that goes down to a very small wood stove. That is primarily just in power outages. Although if you want to light a fire and just sit there and enjoy the fire, it's there. It's actually in the basement, and we set up some venting so that the warm air would rise from the stove and kind of flow up through the rest of the house. So that stove can actually heat that house if we had a prolonged power outage. So foundation plan quickly. Again, you see the house here. The whole south half of the basement is walkout. This you'll see this is all floor heating in the slab. Here's where the wood stove is. There's a structural bearing wall that basically goes down through here, and these black dots represent steel lally columns that support a main girder. There's a U-shaped staircase. Mechanical room is tucked in here on the north side behind the staircase. We put all the plumbing in for a full bathroom in the basement. At this point, the plumbing's in place, but the fixtures aren't. So that's one of the things that got deferred based on just cost and budget. We've got storage over here. We've got a nice area over here that right now is being used as an exercise area. So most of this basement space is livable space. The dimensions on this is 48 feet wide, 32 feet in this direction. The breezeway is 8 by 12, just connects over to the garage. The garage is 24 by 32. And those dimensions are all multiples of 2 feet. So we were able to use what's called 24-inch on-center inline framing. Now, here's part of the work. We got dirty last spring. A lot of people got dirty. When you're dealing with walkout basements, you have step footings, so you have some deeper excavations, and of course, putting these footings in, you're working in the mud, but this is a necessary part of getting a good foundation on a house. So here's another view. You see some footing forms in here. You see some pipes that actually connect between the inside and the outside. So if there was any rising water table, either inside or outside, we have footing drains around the inside and the outside, and we have #2 crushed stone around everything. So we've got a really good drainage layer under the entire basement slab. And here's how you get concrete from a concrete truck in the driveway to just over 100 feet away. That aerial boom was able to place the concrete in those footings. There's about 25, 26 yards of concrete in all the footings. So that's part of the project. Obviously, that's all covered up, but it's hard work. And then the other thing is you'll see a lot of work gets buried. You know, we put in a separate drainage system for all the gutters rather than let the gutters run out on the lawn or just run off the eave. We put in a solid, this is schedule 35 PVC. This is all glued together. And essentially we planned where all the downspouts were going to be located. And we put these risers up and they're all connected together. And ultimately they all drain out because it's a south sloping lot. They all drain out to daylight. So during a rainstorm, this is our system that carries the rainwater away from the building. This does not connect to any interior floor drains, so or footing drains. We didn't want any possibility of a combined drain system. If you do get a plug at the end of that for some reason, and I've learned that lesson the hard way on my own house, if you do get a plug like a cattail root or a bunch of cattail roots, you can actually, during a rainstorm, the water will back up and come up your floor drains. So lesson learned 40 years ago, applied here. Here we are, we're working on a septic system. This is a 30 by 50 leach bed with, I think, 3 big truckloads of crushed stone. So we're leveling some piping in there. Here's one of the early projects. This is where we're rolling out 4 coils of 1-inch high density polyethylene pipe. This is the earth loop installation. And Wayne Hydis, our excavator, he's got a 6-foot bucket on this 25-ton excavator. So he's doing a ditch and we're rolling these coils right down behind him. And again, we're going to get into this in a lot more detail in some of the later episodes. Digging in for the electric entrance. You see the conduit that's going to go in there. Our transformer was about 280 feet away, so we were using some pretty big wire. Put it in conduit. This was, I have to say, this is probably one of the hardest jobs I did on here. We had to put the drainage system in under the slab. If you're going to have plumbing in the basement, like a bathroom, all the drainage lines have to go in. So we're pickaxing here through solid, what we call, I'm trying to think of the term of it now. Very, very hard, undisturbed soil. Hard pan is the local term. You can't touch it with a shovel. So you're basically out there chopping away with a pickaxe. There's no need to go to the gym at the end of the day when you're doing this. So, and then backfilling. We backfilled with sand. So if there was any water, this site does have clay soil. It's not good to put clay soil up against the foundation. You can retain water, and in a cold climate, that water will freeze, and it can push against the foundation. So it's all backfilled with sand. There is footing drains with crushed stone and a permeable paper over that crushed stone, so the sand doesn't wash down in the stone. So again, all this is all buried out of sight at this point, but if you've been involved with construction, you can relate to a lot of work goes into the dirt. And here's what the main floor plan looks like. Again, we've got a garage out here. There is a set of stairs that goes up. These are attic trusses out here. So there's storage up above. The breezeway is the main entrance. So from the breezeway, basically, you can go into the house, you can go into the garage, or you can go straight ahead and go out onto a deck. The house itself, the main living area here, the living room, the dining area, and the kitchen are all one big open area. Okay, there's an island here. It's got 3 bedrooms. Bedroom here, master bedroom over here in the corner. They wanted to integrate the laundry upstairs, so that's integrated into a closet. This is a walk-in closet for the master bedroom, master bath, lavatories, and then a separate little room here with a tub shower, toilet. Here's the staircase. And that space that was left over here, my daughter definitely wanted a pantry, so we built that as a food storage pantry. Bedroom or bathroom number 2, again, just as a general purpose bathroom. And any space that we could, we park closets, lots of closets here. So broom closet here, linen closet down at the end. So that's the main floor plan. I mentioned everything is framed 24 inches on center. Definitely goes faster than 16 inches on center and obviously uses less material. The floor framing is all 3.5 inch wide I-joist framing. So the floor framing literally goes all the way across this dimension. Now there is a center support wall, so it isn't a complete clear span, but two people can move a floor joist all the way across that. That entire floor was framed up before lunch one day. I mentioned attic trusses, both in the house and the garage, and then again our center line bearing here that lines up with the lally columns down in the basement. Here's what it looks like in cross section. Here's the walkout basement. This is an 8-inch poured wall with 1/2 inch rebar, 12 inches on center in both directions. Walkout on the south side. We put a little canopy roof here to provide shading in the summertime over those windows. Here's our main living level. Planning our stairs out here to make sure our stairs would be compliant with the codes. The codes over the years have changed in terms of what they allow for rise and run on a stairs. And these are 9-foot ceilings here. And finally, this is an attic truss. So this space right here, it's 16 feet wide, 8 feet tall. That is basically all, at this point, it's all open space. It's all finished, but that could be divided up into additional bedrooms. It could easily accommodate 1 or 2 bedrooms or a bathroom. We actually did run the plumbing up there, so at some point, if there's going to be another bathroom, it could be tied right in without really starting to do a lot of cutting down below. And the insulation system for the roof is all integrated into that upper truss cord. That's 4 inches of spray foam and 5.5 inches of mineral wool. And together, that's about an R51 rating. So again, that's the area that is living area up above. We did end up with a little platform area here. We use that to hold the air handler for the chill water cooling system. And again, you'll see that in later episodes. And we ended up with another little area over here. I call it the play loft. I'll show you some photos of that. So here it is as of last December. We're almost done. So there's the cabinets that the Amish build. And I'm still amazed. We had a chance to go visit the shop several times. They use a diesel engine, no electricity, a diesel engine that runs a shaft that runs under the floor along the whole length of the shop, cut holes in the floor and bring belts up to run planers and sanders and saws. And they just build beautiful. They're very practical cabinets, very solid, and they build at a very reasonable price. So we consider that just a great asset to use locally. So here's that little space at the top of the stairwell. I call it kitty jail. So here's my grandson, Henry, entering kitty jail. There's a little door here. It's about 16 inches wide, maybe a little over 2 feet tall. And here's the railing. And I'll show you another photo of that. This is me trying to escape from kitty jail here. So there's limited adult access in there. And this is my grandson wondering what's going on here. So at some point, we're thinking we would probably open this up, maybe put a gate here. But for the time being, Heidi and Annie wanted to keep this ultra safe. So this is a solid railing going across here. And here's what it looked like probably about January last year, using the tractor to push the snow off the driveway, first winter in a new house. Now, we had a lot of great people involved in this project, just fantastic people. Our main crew here, Hoban Construction, I've worked with these guys, again, probably about 30 years now. And I call them country carpenters. These guys do a lot, though, and they do it very well. Framing, electrical, plumbing, shingles, windows. They pretty much handle all that. So here they are. Essentially, in one morning, these guys started they start at 7 o'clock in the morning. You can hear the hammers going and the compressors and so forth. by lunchtime on one day, they had that floor deck all framed up. So that's a combination of both hard work and just things like that 24-inch on-center framing. My neighbor, Jack Roskup, is a licensed surveyor, a great guy, came over, brought what's called a total station over, and he and I laid out all the points. Jack is a meticulous guy. We had the corners of this house probably within 1/8 of an inch of where they should be. Okay. And again, here's a shot down in the trenches. We've got the excavator going in the background. My son-in-law, Andy, and myself, and then Harvey Euchre, a good friend of mine who was involved in this project. We're just waiting for Wayne there to dig a little farther. We're going to push those coils down through the trench as part of the earth loop. Here's Harvey getting baked on a nice sunny day in a basement that is basically a cocoon full of styrofoam insulation with the sun shining into it. He's putting in a manifold station there and connecting some tubing to it. Actually, Harvey's son Joel got involved late in the project. He's doing some purging there on that manifold station for floor heating. Okay. Here's Andy and my wife. They're out there putting hay on the leach field. We installed all the pipe, all the crushed stone. And when you put the dirt back on the leach field, you don't want the fine particles in the dirt to leach down into the stone and partially block the ability of water to permeate it. So we just run down the road to the local farm. We get a few hay bales, like 40, and tear them apart, shake them down, and then by evening, that's all covered with dirt. My daughter got involved here. I got her working on the drains out in the garage. She did some of the plumbing on that. And then here's my grandson. Now he's ready to take the controls here on a 4-ton Bobcat with a 65-horse turbo diesel in it. I didn't turn it on yet. Maybe a few more years we'll take him out in the field, let him try that thing out. But I wasn't about to turn that on and let him push those levers, even though he'd like to. Now, so much for the house. We've looked at a lot of the construction of the house. Here's this overall system. And if you glance around on the system here, you'll see there's actually 2 heat pumps involved. The main heat pump is the geothermal water to water down here. But we also use this house as a test site for an air to water heat pump that is just becoming available. It's a space pack product. It's a split system. So the original mechanical system, we had planned to put an electric boiler in simply as a backup or a supplemental heat source for the heat pump. If the heat pump was down for service, we would have an electric boiler that could cover for it. Well, we decided to omit that electric boiler and instead let this house serve as a test site for this air to water heat pump. And again, we're going to talk about these elements in a lot more detail. It's set up right now so that basically there's a 2-stage control. And either of these heat pumps can be configured as the lead stage, and the other heat pump would serve as the lag stage. And it's just simply flipping a switch will reverse which is lead and which is lag. You'll see there's panel rads up here. There's a towel warmer in the master bathroom. There's some floor heating circuits here. There's other floor heating circuits in the basement. And also there's a floor heating system in the garage that is set up with a heat exchanger and an antifreeze. And right in the middle here, you'll see this buffer tank. It's a 119-gallon buffer tank. And you can think of that buffer tank sort of as a hub. The 2 heat pumps both dump heat into it, and then all the heating loads will extract heat from it. In the summer, when the system is changed over to cooling mode, either heat pump can chill the buffer tank, and then there's some pre-insulated 3/4-inch PEX tubing that goes out to this 3-ton chill water air handler, and that's the single zone cooling. So again, oftentimes people will look at a schematic like this and kind of say, wow, how does the water know where to go? It looks so complicated. So what we're going to do in the subsequent episodes is we're going to take that system apart into several subsystems, and you'll see the subsystems use very well-established design techniques, things like home run distribution systems, three-way motorized mixing valves. We tied it all together with hydraulic separation, actually using the buffer tank as the point of hydraulic separation. We've got good air and dirt separation going on, a lot of fundamental hydronic details. We do have some variable speed pumps. Actually, all the circulators in this system are ECM circulators. Some of them, they're all capable of running at variable speeds. Some do, and some are set for fixed speed operation. So again, subsequent episodes, we're going to take this system apart and eventually put it back together again.
That certainly sounds like that. Well, John, I think we're going to wrap it up. I wanted to say a shout out to Dan. We sure appreciate you kicking off this series. To our audience, we've got 3 more episodes coming up, coming at right at the same time on Tuesdays at, as John mentioned, noon Eastern Daylight Time, at 11 a.m. Central Daylight Time. So we sure hope you can join us for those series. And John, thanks once again, and to our audience, we appreciate you being with us.
Oh, enjoyed it very much. Thanks for all the support, Mary, Hot Rod, and Dan.
Yep, you bet.
Nice job. Talk to you next week.